Hey guys, welcome back to Michelle's Sum Journey. I'm Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2008, 10A Problem 17, and it deals with algebra with a little bit of geometry. I hope you all enjoyed this video and let's get started. The problem states an equilateral triangle has side length 6. What is the area of the region containing all points that are outside the triangle but not more than 3 units from a point of the triangle? Okay, so I drew out an equilateral triangle, and so we know that this has a side length of 6. And so we want to find out the area of the region that is not more than 30 units from a point of the triangle. So it didn't say from 30 units from the vertex of a triangle, it just said from a point of the triangle. So that means that, for example, this could be a point, and then so if it's not more than 3 units, then it would be like around that. So let's just pretend that, obviously not drawing a scale, but let's just pretend that this is 3 centimeters. And so if it's not more than 3 centimeters from a point of a triangle, and it's asking what is the area of the region containing all of the points, then it would, for example, be like the area of all of this. And all of these are 3 centimeters. So as I drew out those little lines, we see that we can actually split the area, we can actually split the region up to find the area. So I'm just going to erase all of these lines really quickly. Okay, so for example, I'm just going to draw a 3 centimeter line from each of the vertex. And so if we split up the region, then that means that we could have all of the points that is from this rectangle. So let's just say that this line and this line right here, those make up the 2 sides of the rectangle that I drew, and those are 3 centimeters. So that means that that would be a good distance from the triangle. And then within this rectangle here, we see that we have all of the points that are not more than 3 units from a point of the triangle. And so this is really easy because we see here that the width of the rectangle would be 3, and then the length, which is this, and we perfectly know that that is 6 because it tells us that the equilateral triangle has a side length of 6. And so we can do that with all of the sides. And so these lines that I drew, these are lines that form a right angle to the triangle. And so all of these rectangles, they would be the same. So for these two, they would both have length of 6 and then width of 3. So the area would be 3 times 6, so 18. And so now we have figured out the area. But we see here that that's not all of the region, because what about this part? And some people may completely just forget about this part because they will think, oh, we have all of the parts like these. This area looks like it covers all of the points that are 3 units from the triangle because it covers the length of the triangle, and that area should be all of it. But actually, we have to surround the triangle fully. It says the area of the region containing all of the points outside the triangle. So as long as it is 3 units from a point of the triangle, we have to cover it. So for example, as I drew this line at the beginning, that is 3. And so this little not semicircle, but a little portion of the circle also should be counted towards the area. And so how would you figure out the area of this little portion of the circle? Well, we do know that because it is an equilateral triangle and it actually is in blue. So note here that if the question, not if you print it out and take it on the printed test, I don't think it'll be colored, but I'm pretty sure that some of the important words are bolded for you. So it tells us that it is an equilateral triangle. And so equilateral triangle tells us that the internal angles of that triangle would be 60 degrees each. So we now know that this angle is 60. And then as I mentioned earlier, these angles are all 90 degrees because I drew the lines that are perpendicular to the side length of the triangle. So that means that this is 60. Then 60 plus 90 gives us 240. And then we can just use 360 minus 240, which gives us 120. So we did 360 because we know that this whole thing forms a 360 degrees, and so we can find out the angle of this portion of the circle that we need to find the area of. So we now know that all of the angles for the little portion of the circle is 120 degrees. And so we know that the radius of the circle is 3 because we're just using the line that I drew earlier that represents the length of the 3 units from point of the triangle. So if we know that the radius of the circle is 3 and the area of circle formula is pi r squared, then we know that r, which is the radius, is 3. So that means that we know that the circle, like the full circle, the area would be 9 pi. But we don't have the full circle right here. We have portions of the circle. And so the portion of the circle is 120. That's the degree. 120 out of 360, which is the degree of the full circle. Simplify that, we get 1/3. So we know that each portion here that we have, this portion of the circle, that is 1/3 of a full circle. Okay, and so we have 3 of these. That is completely just perfect because if it's 1/3 of a full circle and we have 3 of these, then 1/3 times 30 gives us 1. So if we put these together, then that gives us 1 full circle, and we know that the 1 full circle, the area is 9 pi. And so we can just add all of these up. We have 18 plus 18 plus 18, that is the area of the rectangle. And then we have 9 pi, and that is the area of the circles. And so without even adding this up, we should be able to figure out that the answer is B, because that is the only one that contains 9 pi. But just for accuracy, we're just gonna add 18 plus 18 plus 18 up. So it'd be 18 times 3, which is 54. And so, yep, the answer is 54 plus 9 pi. So therefore, the answer is B.